Hi students, now we are going to see some examples based on equivalence relation or check whether the following relations are equivalence or not. Now we are going to see some non-mathematical examples. Here is the example. Below is the list of relations among the people. See here, these are non-mathematical examples. These are the relations among us. For example, X is taller than Y, X is a relative of Y, X is a friend of Y, X is a brother of Y, X is a sister of Y, X is a mother of Y, X is a father of Y. All these relations can also be considered in a mathematical way. For that, for each relation, state whether relation is reflexive, symmetric or transitive. So let X be the set of all people. Then X comma Y belongs to X means what? X and Y are persons, two persons. Then X is R related to Y, that two persons are related by the relation R if and only if age of X and Y are same. So we have to check whether this relation is reflexive or not. Here the two persons are related only when their age are same. Let us check the reflexivity. Here the number 1 A, the relation R is defined by X is R related to Y if and only if age of X and Y are is same. Reflexivity, let X belongs to X, let capital X belongs to X, then age of X and X, age of X and age of X, that is age of X and X are same. So X is R related to X, therefore X is R related to X because age of X and X are same, and this holds for all X belongs to X. Therefore R is reflexive. R is reflexive. Second one, we have to check whether this R is symmetric or not. Let us check whether this R is symmetric or not. Symmetricity. For that, let X comma Y belongs to X. Suppose X is R related to Y. This implies that age of X is R related to Y, X and Y are related, age of X and Y are same. This implies that age of Y and age of X are same. This implies that, here by the definition, X is R related to Y, X is R related to Y if and only if age of X and Y are same. Here age of Y and X are same, thus this implies that Y is R related to X. Thus this relation R is symmetric. Therefore R is symmetric. Similarly, this R is transitive also. Why this R is transitive? Transitivity. Let us check transitivity. How you can check the transitivity? For that, let X comma Y comma Z belongs to X. Suppose X is R related to Y and Y is R related to Z. This implies that X is R related to Y means what? Age of X and Y is same, and Y is R related to Z means age of Y and Z is same. This implies that age of all these three persons X, Y, Z are same. This implies that age of X and Z are same. Why? Because age of X and Y are same and age of Y and Z are same. So age of X and Z are same. This implies that X is R related to Z. Therefore, whenever we have X is R related to Y and Y is R related to Z, we get X is R related to Z. Therefore, this relation R is transitive. Therefore, this relation R is transitive. Thus, from 1, 2 and 3, from 1, 2 and 3, capital R is equivalence relation, is an equivalence relation. Equivalence relation is an equivalence relation. Similarly, you can check whether this given relation, second relation, is equivalence or not. How you can check? See here, x is r related to y. I am not going into the details of this. Only I will give a hint. So x is taller than y. X is taller than y means what? X is taller than y. X and y are related if and only if x is taller than y. See here, x is not taller than x. This is not reflexive because x is not taller than x. Because height of x and x are same. Not taller than x. Not taller than x. Therefore, this r x is not r related to x by this relation. For the second, x is not r related to x. So therefore, this relation is not reflexive. Second relation is not reflexive. Similarly, if x is r related to y, x is taller than y, that does not imply that y is taller than x. Therefore, if x is taller than y, then y is not taller than x. Y is shorter than x. Therefore, this is not symmetric also. Not symmetric. Similarly, if x is taller than y, this is transitive. X is taller than y and y is taller than z, then x is taller than z. X is taller than y and y is taller than z, then x is taller than z. So this is a transitive relation. This is a transitive relation. So this is not reflexive, not symmetric, but transitive. Similarly, x is a relative of y and y is a relative of x. X is a relative of x, so this is reflexive, symmetric also, and transitive also. X is a relative of y, y is a relative of x, then x is a relative of z. So in this way, we can check whether the given relation is reflexive, symmetric or not for a non-mathematical example, that is a relations among the people. You may take here, you may define here x is r related to y if and only if x is a father of y, x is a sister of y. Likewise, the relations among the people can be considered as a relation on a some set x where x is the set of people. Thank you, student.